What is up, my friend? Danny here from youngat30.com, and in this video I'm going to talk about how we can improve the quality of our sleep through light exposure. So first of all, let me talk about why sleep is important. Now, a really good obvious reason is when we get a good night's sleep, we feel great in the morning, we feel refreshed, we feel more awake, we feel more alert through the day, we have more energy, and just our general mood and well-being is much better than when we get a bad night's sleep. When we get a bad night's sleep, we feel lousy, we feel drowsy, we feel tired, we have no energy, we just don't feel very well, basically. So that's a good reason I think we can all relate to and we've all experienced. Another important reason is that when we sleep, a whole raft of healing processes kind of run in the background, and these processes are critical for our health and critical for disease prevention. We now actually know that people that have really poor sleep have multiple-fold increased risk of metabolic disease, of cardiovascular disease, of diabetes. They actually have a 4-fold increased risk of cancer. So it's really important that we get a good night's sleep so these healing processes can run in the background. Another interesting thing is there's been a recent study that showed when we sleep, the space between our brain neurons actually expands, and that allows room for secretion of this kind of goopy crap that comes out of our cells, and it's washed away by our cerebral spinal fluid. So when we're sleeping, our brain's getting this really kind of powerful cleanse, which is pretty fascinating stuff. So there's a few reasons why sleep is really important and critical to our health. So how do we improve the quality of our sleep through light exposure? First of all, I need to talk about how light impacts our sleep. So sleep actually turns out to be what's called a circadian rhythm, and we have many circadian rhythms, and a circadian rhythm is basically a repeatable cyclic process that happens roughly every 24 hours. And in the case of our sleep circadian rhythm, it's governed by the night and day cycle, and we've actually evolved to adapt to this night and day cycle. So as we go through the seasons, obviously the sun will rise at different times and it will set at different times, but we naturally adapt to this by resetting our circadian rhythm. The same thing happens when we go abroad to another part of the country where there's a big time difference. At first our sleep is really lousy because our circadian rhythm has been disrupted, but eventually, gradually with time, our circadian rhythm resets itself and we marry up with a new night and day cycle of this country, and we sleep at night and we're awake during the day. Now, it turns out that the medium between this external night and day cycle and our internal circadian rhythm is something called, well, it's a system in the brain called the suprachiasmatic nucleus. Now, I'll say that again because it's quite a mouthful. It's called the suprachiasmatic nucleus, and the suprachiasmatic nucleus is the master regulator of our circadian rhythm. It controls when we sleep, when we're awake, and those healing processes I mentioned at the start of the video, it regulates those through the expression of genes. It tells them when to turn on and when to turn off, so it's really important. Now, interestingly enough, a recent study has shown that if you take a healthy hamster and you remove its suprachiasmatic nucleus, it will lose its circadian rhythm, it will lose its sense of night and day, it will stay up during the night time, and it will fall asleep at random hours of the day for hours at a time. More interestingly, if you then take the suprachiasmatic nucleus of another hamster and you put it into the original hamster, that hamster regains its circadian rhythm and it can sleep at night and be awake during the day. So that's why we know that the suprachiasmatic nucleus is a master regulator of our circadian rhythm. Now, the problem is, in our modern society and our modern environment, we are actually confusing the suprachiasmatic nucleus by giving it mixed signals of when it's nighttime and when it's daytime. It's not a clear-cut message. So basically at nighttime we're using artificial light, we're using our cell phones, we've got TVs, we've got computers, and we're getting artificial light when we shouldn't really have any light. And during the daytime, a lot of us spend most of our time indoors, so we're not getting full exposure to sunlight, and that also has an impact as well. So what we're doing is, I mean, this goes completely against what our ancestors would do. They would get up in the morning and they would be out in sunlight all day, and when the sun went down, that was it. There was no more light apart from the campfire. So what we're doing is we're disrupting our circadian rhythm, we're confusing the suprachiasmatic nucleus, and it's messing up how it regulates these genes to turn on these functions that we need when we sleep. It's called asynchronization, where we kind of really mess up its rhythm. And that's the problem with modern day society. It's impacting our sleep. But the good news is we actually have some control. We can mitigate this impact, and that is through the exposure of light, or controlling our exposure to light. So I've mentioned that we confuse our suprachiasmatic nucleus by not giving it a message of when it's nighttime. Now, the most powerful thing that we can do if we want to get good quality sleep is we want to let the suprachiasmatic nucleus know in no uncertain terms when it's night time. We want to give it a clear-cut message, and that's the kind of core message of this video. That's the crux of it. I'll say it again. So in order to get good quality sleep, we want to let the suprachiasmatic nucleus know clearly that it's night time, and the most powerful way that we can do that is through the production of a sleep hormone called melatonin. Again, I'll say that again. The most powerful way that we can let the suprachiasmatic nucleus know that it's nighttime is through the production of a sleep hormone called melatonin. Now, I used to think that melatonin was a sleep hormone because it made us sleepy and drowsy. It turns out it doesn't actually do that, but what it does do is it really reinforces the message to the suprachiasmatic nucleus that it's nighttime. That's how it does it. Now, melatonin is made under what's called dim light melatonin onset, and dim light melatonin onset is what happens when the intensity of light reduces and the tone or color of light changes, so we get less blue lights. So again, I'll say that again, the melatonin that we make increases in its production when the intensity of light reduces and the tone or color of light changes, so we get more blue lights. So light is really an important player when it comes to the production of melatonin. Now, how do we know that? Well, it's quite interesting. There were two clues. So number one, we knew that people that did not have eyes, obviously they can't see, but people that don't have eyes, they cannot reset their circadian rhythm, which is interesting. But also people that are blind, but they do have their eyes still, but they're blind, they can't see, they can reset their circadian rhythm. So as they go through the seasons and the time the sun sets changes and the sun rises changes, they will adapt to that, and they will sleep at night and be awake during the day. So those were the two clues. So scientists knew there must be some kind of receptor in the eye that is telling the suprachiasmatic nucleus that it's daytime or nighttime. And it turns out a number of our retinal ganglion cells, they're called melanopsin, do this. So as opposed to the rods and cones in our eyes that are kind of involved in seeing, what they do is they take a light signal, they convert it to a nerve signal and send that to the primary visual cortex. What the melanopsin do is they take a light signal and they convert it to a nerve signal, but they send it to the suprachiasmatic nucleus, and that tells it when it's nighttime and when it's daytime, which is important. So light is a key player when it comes to melanopsin production. So to make more melanopsin, we want to reduce or limit the amount of intensity of light we're getting and reduce the amount of blue light we're getting. So what we really want to do, we want to kind of replicate what our ancestors would do. So as I say, they would get up in the morning, they would be exposed to sunlight all day, and when the sun goes down, they have no more light apart from the campfire. Now, interestingly enough, a fire has very little or no blue light in it at all. So the melanopsin, these receptors aren't telling the suprachiasmatic nucleus that it's daytime. So we know to make more melatonin, and that reinforces the message to the suprachiasmatic nucleus that it's nighttime, so it can run all those core functions and processes. So that's what we want to do. We want to reduce, when the sun goes down, we want to reduce the intensity of light, and we want to change or ensure the tone of light that we're getting contains as little blue light as possible. Now, I will talk about 4 ways in which we can do that. Now, the first way is to kind of get rid of our conventional light bulbs that we have at home, and we want to use red light at night. Now, I actually use something called a Philip Hughes light. Now, you plug it in and you set it up to the internet and you control it with your phone. And basically, in daytime, you can use blue light, but at nighttime, you can change the settings. So you just get red light, it filters out all the blue light. And you can have different settings like tropical sunset and all this stuff, but it works really well, easy to control. So that's the first thing you want to do, is get rid of your normal light bulbs and use red light at night, ideally ones that contain both, so you can switch between the two. You don't have to kind of change your light bulb every time. So that's method number 1. Method number 2 is actually using blue blocker glasses. So when the sun goes down, put on your blue blocker glasses, and what that does, it just filters out all the blue light you're getting from all these various sources. So that will help with the production of melatonin and help us sleep. And these are relatively inexpensive. You can get some on Amazon for about £30, I think. So just put those on and that will really help with the production of melatonin. So that's method 2, blue blocker sunglasses or just glasses. Method 3 is using filters on our laptops and our cell phone. So I'll talk about cell phone first of all. So obviously cell phone has lots of artificial blue light, but I actually use an iPhone that has a built-in function where you can kind of filter out the blue light, and you can also put it on a timer. So when it gets to sunset, basically, it will stop emitting blue light and you'll get the soft red light instead. So that's a great way. On your laptop, you can actually get programs that filter out blue light. The one I use is called Flux, and again, same kind of principle. You can put it on a timer, and when it gets to sunset, it will filter out the blue light. And if you don't have an iPhone, I think you can get Flux for your cell phone as well to stop the blue light. So that's method number 3, put filters on your laptop and your computer. Method number 4 is to do with the environment you're sleeping in. So when it actually comes to bedtime and you're asleep in bed, or you're trying to get to sleep, you want to make sure your environment is as dark as possible, ideally pitch black. So anything that emits light you want to turn off. Turn off your cell phones, turn off your your stereo and all that stuff, so there's no light being emitted at all. And you want to make sure you've got really thick, heavy curtains, or ideally blackout blinds. What you want to do is make sure it's pitch black, and this will really help with your quality of sleep. Obviously, with no light at all, those melanopsin receptors in your eyes are not going to get any signals at all, and it'll be very clear to the suprachiasmatic nucleus that it's night time and it's time to sleep. So that's method 4, make sure it's pitch black. So let me talk about those methods again. Number 1, you want to use red light at night, so get rid of your conventional light bulbs and get a red light bulb, or get one that changes, like a Philips Hue one. Number 2 is you want to use blue blocker glasses. When the sun goes down, that will filter out all the blue light. Number 3, you want to use filters on your laptop and your cell phone, and you can do that. It's either built in, or you can get programs like the one called Flux. And number 4, you want to make sure you sleep in pitch black conditions. So those are the 4 ways. So let me just do a brief recap on everything we talked about, because it's quite important. So number 1, sleep is really critical, because when we sleep, we get a lot of kind of core functions run in the background, and they're critical to our health and critical to disease prevention. And people that don't get good sleep are at higher risk of getting disease. So we want to make sure we get a good night's sleep. Now, the key to getting a good night's sleep is telling the suprachiasmatic nucleus that it's nighttime, and the most powerful way we can do this is by producing a sleep hormone called melatonin, and this is done through dim light melatonin onset. But the brighter the intensity of light and the more blue light we get, that actually inhibits the production of melatonin. So you want to kind of mimic what our ancestors would do and get less blue light at night and less intensity, and we can do that 4 ways. We can do that, number 1, through changing our lights to red light. Number 2, through using blue blocker glasses to filter out the blue light. Number 3, we want to use filters on our laptop and our computers. And number 4, we want to sleep in pitch black condition. So that is a video. I hope you enjoyed it. There's a lot of information in there, and there's a lot more available out there as well if you want to research further. So until the next video, have a great day. Oh, I forgot to mention, if you did enjoy the video, please click the like button, leave a comment if you want to comment or you have any questions, and if you'd like to see more videos like this one, hit the subscribe button and you'll get notification of those. So thank you so much for watching, and have a great day.